Hello everyone, I welcome you to this presentation, and today I am bringing you a video on the concept of 3 by 3 matrix by elementary operations. In the previous video I explained you the concept of 2 by 2 matrix by elementary row operations. Today we are going to explain you the elementary operations on our 3 by 3 matrix. I am starting my presentations with a great saying by George Cantor: the essence of mathematics lies in its freedom. Okay, students, like in class 12, these elementary operations is one of the most important concept, and I can tell you that with the help of my presentations, I'll try to make this concept as simple as possible. Okay, so we'll be taking our questions based on NCERT text, and I'll show you the simple trick how a 3 by 3 matrix can be solved. Okay, let's start with a question. Okay, before we go, and I'll be explaining you the properties, that is rule of elementary operations, and in the previous video also I explained you that there are 6 rules of elementary operations. 3 rules are due to rows and 3 rules are due to columns. Okay, now if we take a question on our 3 by 3 matrix, find the inverse of A. We are going to find out the inverse of this matrix with the help of elementary column operations. And students, you should know that when you start questions with the help of elementary column operations, here always this important step you need to remember, always you should write a matrix A is equal to AI. Okay, so what will be our next steps? Next step, this A and this A in the right hand side A, you don't need to write the whole matrix A, you need to only write A. And in place of I, you should write I means 3 by 3 identity matrix here. Okay, now what will be the steps we will be following? Okay, our intention, our objective in the left hand side matrix, with the help of certain elementary column operations, we need to convert this matrix to an identity matrix. And you don't need to worry about the right hand side. This A, matrix A, you need to keep only writing, and the moment you will be operating some elementary operation on the left hand side, definitely the same rule to be followed for the right hand side. Okay, now as I said before, that actually this concept, okay, is you can say a play on numbers. We have got 9 numbers. What I'm going to do is, you are going to change this one to an identity matrix. This is your main objectives. Okay, now look, what is an identity matrix? You want to convert this one to an identity matrix. This diagonal elements you need to convert to 1. That means this 2, 2, 2, this all 3 2's you need to convert to 1, and all non-diagonal elements -3, 3 and 3, and 2, 3 and -2 you need to convert to all 0. Okay, so how can you do that? So it's one important and very basic rule coming to my mind, that if you compare column 2 and column 3, so if you add column 2 with column 3, what do you get? That -3 and 3, 2 plus 3 is 5, -3 and 3 is equal to 0, and -2 and 2, if you add, you will get 0. So the first rule we are going to apply is C2 plus C2 plus C3. That means we are going to change C2, that is column 2. Okay, then if we add this, -3 and 3 is 0, 2 plus 3 is 5, -2 plus 2 is 0. Student, you should know why it's these steps you have started. Okay, you know all non-diagonal elements you need to make 0. So if we simply add these 2 columns, you are going to get out of the 3 numbers, at least you are going to get 2 numbers 0, and you are getting a 5 here, so that will also give you an advantage for these steps. Why? Because what could be the next steps, probably it's coming to your mind, is the column 2. If you divide by 5, you're going to get 0, 1, 0, and I know the second column has to be 0, 1, 0. Okay, so same rule, if you are following this rule, that means you are adding column 2 and column 3. In the right hand side also you are doing that. 0 plus 0 is 0, 1 plus 0 is 1, and 0 plus 1 is 1. Okay, let's move to the next steps. Okay. Now, if you are here in the previous slide, okay, we can think of a relation between the column 1 and column 3. What is the basic relation between column 2 and column 1 and column 3? What is that? That if you add column 1 and column 3 elements, the 2 plus 3, 2 plus 3, 3 plus 2, that is also a very interesting relation between column 1 and column 3. Therefore, in the next steps, we are going to use the rule that C1 implies C1 plus C3. So it should be in your mind that why we'll be doing that. Okay. So in case if you add C1 and C3, you are going to get all the entries in the first column as 5. So that will also give you a big advantage in these questions. So let's see why. You are getting, after addition of the column 1 and column 3, you are getting all 5s in the first column. And already you know that in the previous step already you got 0, 5, 0. Okay. Now what should be a very simple steps in the second, okay, in the following steps. What is that? The column 1 you are going to divide by 5 and column 2 also you are going to divide by 5. Okay. In case if you divide column 1 by 5, you are going to get all the entries in the column 1 as 1. You are going to get all the second element 5 is 1 and other two entries will be 0, 0. So therefore the second step will be column 1 will be 1 by 5 column 1. Okay. So if you divide column 1 by 5 it will be 1, 1, 1, and if you divide column 2 by 5 it will be 0, 1, 0. Similarly we will be following the same rule for the right hand side matrix. So we will be dividing 1 by 5, so it's 1 by 5. We will be dividing 0 by 5, so 0, and 1 by 5 is 1 by 5. And similarly, there will be changes on the second column. It will be 0, 1 by 5, 1 by 5. Okay, now, have you seen, there are a lot of changes coming up in the left hand side matrix. Okay, so we are getting at least some of the elements of column 1 and column 2, you have changed to 1 and 0. But don't worry that, yes, we need 1, 0, 0, but we are getting 1, 1, 1. Yes, fine. At least instead of getting other numbers, you are getting 1, 1, 1, and the following steps we are going to change this 1, 1 also. Okay, now you should be now concerned about which column. You should be concerned about the third column now. Okay, so this 3, 3, 2, we have to make some changes on this number. So if you try to make this 0, how can you do that? So if you can make 3, 0 with the help of the column 1, how can you do that? This 3 you can subtract from the first column, but before that you need to multiply column 1 by 3. So therefore the easy steps coming up, the next is this, that column 3 will be column 3 minus 3 into column 1. So what will be the numbers? What will be the column 3 in that case? 3 minus 3 into 1, it will be 0. 3 minus, okay, 3 minus 3 into 1, it will be 0, and 2 minus 3 into 1. So what will be this element now? 2 minus 3 into 1, that is 2 minus 3, it has to be minus 1. So we can see in the next, so it will be 0, this will be 0, and this will be minus 1. So let's see what happens in the next. Okay, here. Now, what are the changes will take place for the third column? So you are multiplying this one by 3 and you are subtracting. So it has to be minus 3 by 5, and both the entries are 0. So there will not be any change on this number. Now what will be the change on this number? You are multiplying this number by 3 by 5 and you are subtracting this number from 1. So it will be obviously 1 minus 3 by 5. So what is 1 minus 3 by 5? 1 minus 3 by 5 obviously will be 2 by 5. So what you can see in the next steps. So it will be 2 by 5. Okay. Now please observe this particular matrix. So this matrix is 1, 1, 1, 0, 1, 0 and 0, 0, minus 1. So what the next rule we are going to follow is, so how can you make this minus 1 as 1? So you can simply multiply the column 3 by minus 1. So if you multiply the column 3 by minus 1, it will be 0, 0, 1. So have you seen that? It is 0, 0, 1. Only what number we need to make changes in column 1, we need to make this 1, 0 and this one. That means we need to make 2, 1 position 1 as 0 and 3, 1 position element to be 0. So how can you do that? So in this steps we are going to follow the two rules in the same steps. Okay, so what is that? C3 we are multiplying by -1, and C1, this one, that is 2 1 position element, we will make it 0. How can you do that? If you subtract column 1 from column 2, 1 minus 0 is 1, 1 minus 1 is 0, and 1 minus 0 is 1. So next steps we are following that column 3 we are multiplying by -1, and column 1 we are changing with the help of the column 2. That means column 1 minus column 2. So let us calculate. 1 minus 0 is 1, 1 minus 1 is 0, and there will not be any change of this number because 1 minus 0 will 1 remain. And we are multiplying column 3 by -1, so it will be 0, 0, 1. Okay, now go for these steps. Okay, here also you are going to do that. 1 minus 5 minus 0 is 1 by 5. 0 minus 1 by 5 is minus 1 by 5. 1 by 5 minus 1 by 5, it will be 0. And there will be more changes on the column 3. You are multiplying column 3 by -1. Therefore, minus 3 by 5 into -1 is plus 3 by 5. It will be 0, and this number will be minus 2 by 5. Okay, students, you are very, very close to the answers. What is left out? It is left out only one particular number. What is that? That 3 1 position elements. So I hope by this time this steps is coming to your mind. What is that? Yes, this element you need to make 0. How can you do that? So you can utilize column 1 and column 3. Simply column 1 you subtract from column 3. So 1 minus 0 is 1, 0 minus 0 is 0, 1 minus 1 will be obviously 0. And similarly in the right hand side, 1 by 5 minus 3 by 5. Okay, so we are going to get minus 2 by 5. So minus 1 by 5 minus 0. There is no change on this number. And 0 minus 2 by 5, it will be plus 2 by 5. What you can see in the next slide. Okay, this is 1 0 0, this is 0 1 0, this is 0 0 1, and in the right hand side you are getting minus 2 by 5, minus 1 by 5, 2 by 5. There will not be any change on column 2 and column 3. And finally, what is in the left hand side? The left hand side is that identity matrix. This is A and this is another matrix. We know with the help of the definition that I can show you. Okay. That if there is a matrix A and there exists another matrix B, and if AB is equal to I, then this B is said to be the inverse of A. Okay, so you can see that here the left hand side is an identity matrix, and right hand side this is A and this is another matrix. Therefore, this matrix will be the inverse of A. And finally, our answer is the inverse of A will be minus 2 by 5, minus 1 by 5, 2 by 5, 0, 1 by 5, 1 by 5, 3 by 5, 0, minus 2 by 5. Okay, this is so throughout the process you have seen that like we are following certain simple trick to find out the inverse of the matrix. And remember one thing, that while following the rules, okay, this is not fixed that these are the rules you need to, these are the steps or these are the operations you need to follow. You are free to apply the correct rules. Okay, and remember one thing, since this question have started with the column, we are not shifting to row operations. This is not allowed. Okay, now I hope with the help of lots of practice on 3 by 3 matrix, this 6 marks in the board exams should be very, very simple for you.